Hello and welcome to the workshop on data visualization with Hanami. Our speaker today is Kira McLean, and I will let her take it from here.
Okay. Hi, everyone. Yeah, so I'm Kira. Welcome to this workshop on Hanami. And thanks for coming. So yeah, my name is Kira. I'm a Clojure developer. I do mostly web development. I'm working primarily with a UK-based company called Swirl. And it's basically a sort of open data publishing company. So just a quick intro to this, I guess, yeah, not sure exactly what everyone's background is. So just to give you an idea of what we're going to cover. It'll be just a sort of very basic overview of what's possible with a couple of libraries that are available in Clojure for data visualization. And we'll assume some just kind of basic familiarity with Clojure, but no specific experience with any of the actual tools we're using here. So as we go, pretty soon I'll show you how to get set up with the sort of project and libraries that we're going to be using. And if you like, you can follow along. But I'll assume that you have a running Clojure environment and a Clojure IDE and everything like that. And so we won't spend too much time on that part. But yeah, the goal is that by the end of this, everyone can feel comfortable creating at least sort of really basic little graphs and charts with this cool library. So just to give you an idea, a couple quick things we're going to cover is just Vegalite and Clerk, and these are some of the sort of underlying tools that we're using in this workshop. And then we'll cover Hanami itself and kind of how does it work and what's it do and what's its connection to Vegalite. And then we'll spend hopefully most of the time just practicing and exploring together, see what's possible. So yeah, so there's a lot of stuff there. Not sure if anyone's heard of Clerk before, but this is the just a really brief background about the tool we're using here to sort of visualize these, like kind of render the stuff in a browser. So Clerk is, there's a link here. Oh, I should mention before we get, well, I guess we have started, but just in case anyone wants to follow along on their own, I'm just looking for the Zoom chat. Or maybe, where's the best place to post links? Maybe more in the Zulp.
Yeah, I think in the Zulp would be better.
Okay, so actually I have posted already. So in the Zulp, there's a link to a GitHub repo there. If you want to follow along, or if you want to use it as a starting point for your own explorations, you can start there. But anyway, so yeah, Clerk is this Clojure library that basically turns a namespace into a notebook, which is you're probably familiar with if you're in the kind of data world at all. But a notebook's basically just like an HTML page that you can render in your browser. So it also comes with all kinds of stuff built in that makes data exploration like this really easy. So like, for example, this file watcher and renderers for all different kinds of data, including Vegalite specifications, which we're going to use today, which Hanami kind of builds on top of. So right away here, let's, if anyone, I guess you obviously don't have to participate in that way or follow along if you don't want to, but if you would like to try things on your own machine as we go and kind of play around as I'm explaining things, now would be a good time to get a new project set up on your computer. So like I said, there's a repo there in the Zulp chat that you can just clone, and the main branch should just be a sort of skeleton project. Or you can make a new Clojure project however you like, however you normally do, and then just include these dependencies. These are the only ones we're going to need today. And then go ahead and create a new file called Hanami CLJ. Doesn't necessarily have to be in the workshop, but anyway, make a new namespace that looks like this. And so I've got, oops, this one here. So my namespace is just a Clojure file. And this is one thing about Clerk, so you can see like all these comments are just markdown sort of format comments in here. But anyway, the actual Clojure parts get get rendered. So this is the relevant parts, the requirements, and then start up a REPL. So I've already got one going here because I'm obviously showing you guys this as we go, but start up a REPL and then just run these 2 lines. So it doesn't necessarily have to be on this port, but this will get clerk serving your namespace as a notebook, and then this tells it which namespace to show. So if there's anyone that has any questions about that or any issues, or anyone, yeah, who wanted to get that set up. Okay, sounds like we're all good. So cool. Now I'll just focus this for a minute because this is the main stuff. So like I said, we'll just go over a quick kind of overview of Vegalite, because it's kind of the underlying library that's actually rendering the visualizations and doing the heavy lifting. But hopefully we'll just cover enough of the basics that so we can know like enough to use it. So anyway, basically Vegalite is kind of described as a grammar for graphics. So almost like a language, basically, but instead of describing like arbitrary computer instructions, it has this language for describing visualizations. And it effectively is JSON. Like Vegalite, if you're thinking of it as a language, it's a subset of JSON. But there's different ways to think about it. So anyway, yeah, as a grammar, if you think of it that way, it's made up of kind of words, like parts of the language, and then rules for combining those parts. And so in Vegalite, you have these pieces or these words, so to speak, that you combine in different ways. And then you basically just tell it what you want to build, and it'll sort of magically turn that into a cool graph in your browser. So yeah, so these are the key ones. It's not super important to know like a whole lot about them, but they're pretty self-explanatory. So data is just the actual input. Usually it's a CSV or JSON file or sort of raw source to a raw URL. Then we have mark, which is the actual type of like physical graphic to use. So like a line or a point or a bar or whatever. Encoding is telling Vegalite how to map between the data and the marks. So like which fields to use which marks for. Transform is pretty interesting. So Vegalite supports all kinds of transformations that you can do on the data, like at visualization time. So if your data is not necessarily like already in the format that you want, you don't have to do a bunch of like pre-processing or whatever. I mean, and transformations can also be useful so that you can use the same data set to support multiple graphics without needing to like generate different versions of the data set or something like that. And then there's a couple others that are less common, or that I guess so far I've seen not used as much, but anyway, scale can just obviously tell you like how literally like how big the graphic should be. And then we have guides, which are things like legends and labels and all the kind of metadata that explains the visualization itself. And then with these, so with these pieces, these sort of words, so to speak, you can combine them to make graphics, or thinking about it as a language, like phrases. So you can concat them together, which is self-explanatory, just like put them in a line, either horizontally or vertically. You can layer them on top of each other, repeat them. You can facet them, which is like having multiple graphs with the same data, but sort of visualizing a different dimension of that data. That makes sense. Anyway, so this is, so hopefully just kind of a super quick crash course or brief intro to Vegalite. So just to get an idea of kind of what it even is, hopefully. So yeah, this one is quite involved, but this is an example of a Vegalite spec. So this one is really just copy pasted from the examples in the Vegalite docs, which by the way are really good. But just to give you a sort of concrete example of what this all means. So as you can see, it's just, so this, yeah, like I said, I guess this is cribbed directly from the Vegalite docs, but then I converted it from JSON to Eden. But other than that, it's the same. So we've got the data key here, or the data piece. In this case, it's just a URL to a raw CSV. So if we look at this, it's just going to be tabular data. And then we tell it how high and how tall. We have these transformations here, some encodings telling it, you know, which values to use for the X and Y axes, and then some layering stuff, which is giving us these numbers. And then, as I mentioned before, just quickly, Clerk includes a bunch of different sort of helpers for rendering different types of data or visualizing different types of data. So, and one of those is Vega-Lite. So if you just give Clerk a valid Vega-Lite specification, it will render it in the browser using Vega-Lite. So that's what's going on here. So as you can see, this is like a pretty cool graph, and there's a lot going on here. And this isn't necessarily like, this is still a lot of information, but it's all just purely declarative. Well, except for this stuff, I guess, but kind of straightforward, like telling Vegalite what to do, as opposed to like if you've ever worked with more sort of lower level graphing libraries like D3, for example, it's a lot more about explaining like how to actually draw these lines and whatever. So anyway, so this is a pretty cool one. Yeah, so this one, just wanted to show you quick examples. So, okay, so that's all we're going to talk about as far as Clerk and Vegalite and everything. What questions do you guys have so far, if any? Give everyone a second to, don't be shy. Oh, there's a chat here. Okay, I found it. Okay, well, if that sounds all good, then we'll move on to the main event, which is obviously Hanami. So Hanami is a Clojure, well, yeah, so there's different ways to think about it. So one way is as a Clojure wrapper for Vega-Lite. So Vega-Lite is obviously this kind of JavaScript-based framework for visualizing data, and Hanami adds another layer of abstraction or simplification almost on top of it, but it's in Clojure. But you can also think of it just as its own thing, a kind of declarative.
Careful.
Hello. Sorry? Oh, someone, okay, that was maybe an accent. Yeah, anyway, so just, it's a declarative composable, it's kind of library for building up these templates for visualizing data. And so in Hanami, a template, so that's a word I'm going to say a lot. Template is basically just a map in Clojure, and it's made of these substitution keys. And so substitution keys is another thing that's going to come up a lot. So template is just a Clojure map made up of substitution keys. And the key thing in Hanami is that these substitution keys get replaced recursively, and you can, that sort of is like the key thing that allows you to like build up little pieces of charts in different ways. So we'll get started with some actual like exploration now. So yeah, again, feel free to follow along and try things out on your own computers if you want, or just kind of watch. So Hanami comes with a bunch of default values that are defined in the library already that you can use as starting points. So I just mentioned this early on because oftentimes I find myself wondering, like, you know, if a graph's not looking exactly the way you expect, it might be because there's some default value that's being used that you weren't like expecting it to. So anyway, if we check out this graph or this map, so these are all the ones that are sort of baked into Hanami. And if you want to get a specific one, we can use this helper, which is in the Hanami core, or sorry, common namespace to get a specific default value. So like, for example, in this case, the default value for background is floral white, which is actually like almost a yellowy color. But anyway, that's what the default substitution keys are. And then in Hanami, we've got a few key functions. So the main one is this transform here. And this is kind of the like starting point for most transformations. You give this transform a map of things and it replaces all of these substitution keys. So just to get started, like to see that, what that looks like, I guess I don't really need to run this at the REPL, but yeah, you can see here, if we transform just this arbitrary map. So we saw earlier the default value of background is floral white. And if we, sorry, that's distracting. Turn that off. Yeah, if we replace, if we, pass this map to Hanami's transform function, all it's going to do is sub in this value here. So the other thing, like I mentioned, is that transformations are recursive. So if we inspect the default value for tooltip, maybe if I show it in the REPL, it'll be easier to tell. So the default value for tooltip, so you'll see like the values can themselves refer to other substitution keys. So the default value for tooltip is defined in terms of these sort of X and Y attributes. And then if we want to return, sorry, if we want to sort of, build up a map that uses one of these sort of compound or like recursively defined values, what you'll see is it turns it into this. So we've replaced X with the default for X, and we've replaced type with the default for X type, which is quantitative. And then you'll notice these are missing. And so this is a good time to bring up this like remove value, or this like special key, so to speak, that basically instructs Hanami to like delete that key from all the maps. So if we check out the default for this one, oops. Sorry, I can't type when other people are looking. You'll see it's this special like value that's defined in Spectre. So this is just an implementation detail. Hanami uses Spectre under the hood, which is like a Clojure library for manipulating maps. But it's the same. It's just an alias. This remove is just an alias for that. And that if you include it in a template, it's basically gonna at the end effectively desoak this key. So so that's basically how it works. And you can see here, right? So if we fill in our map with the default value of the tooltip, we get this. But then if you want to replace like just the X field, you get this. So here's your custom value. And so that's, just kind of at a basic level, a high level, how the sort of substitution stuff works, and how this like key Hanami function, this transform function works. So the next thing we'll look at, I was thinking, is these built-in templates. So Hanami, so like I said, Hanami is basically just like another layer on top of Vegalite. Ultimately, what it does, it does lots of things, and we're only going to cover like a small portion of what it's capable of today. But one thing that it does is generate these Vegalite specs, and that's what this transform thing is all about. So it includes a bunch of helpers and like other kind of basically maps, like definitions of Clojure maps that are like a shortcuts for visualizing or generating these specs. So if we look at, like, for example, this one, the view base, all it is a Clojure map here with several default values filled in. And, you know, remember, some of these have that default value of none or remove. So they're not actually going to end up in the final, the final one. But you'll see, so yeah, if we transform this view base and we pass it through this Hanami transformation, we get all these default values filled in. So that's what we're starting with. But you'll see if right here, it's not quite a valid Vegalite spec yet. So because the main thing that's missing is data. So we've got our encoding and some other sort of visual like metadata. But if you remember back to the sort of Vegalite like key, whatever, components or words or whatever, one that we need is a definition for the mark, which mark to use, and one is obviously the actual data source itself. So Hanami also supplies several common chart templates and other useful sort of little template pieces. One is this point chart, for example. So you'll see it's basically the view base with some extra information for the mark, and it's going to generate little circles. We've got like bar charts, and there's all kinds of ones you can explore. Like, yeah, line, text, area, there's all kinds of different ones built in. And these are not, like, by no means the full extent of what you can build with Hanami or Vegalite. It's just like a few of the most common kinds of charts to make it easier. So yeah, I'll copy this to the other namespace, just maybe because that'll be easier to follow. Oops. Okay. So yeah, like I said, if we have just, it's just going to reload. Okay. Right. So if we have just an empty point chart like this, the defaults that are supplied by Hanami, we're not going to see any actual information, obviously, because we don't have a data source. So for this example, what we can do is provide it with this one. This is just a sort of dummy data set from the Vegalite docs. If we look at it, it's just a list of kind of like objects or rows, so to speak. So if we include this, we can see what happens. Oops. I gotta get the auto refresh stuff working. Anyway, so yeah, so just including the data isn't enough because we haven't told it how to map that data to the like circles or the marks that we're using in this case, which are points. So if we look at that data again, we've got these fields here. And so what we can do is tell it, okay, use for the x-axis horsepower and for the y-axis miles per gallon. And we're getting those from here. So that's why they have to match exactly. And it would be cooler if this reloaded itself. Anyway, so yeah, so this is how you get like just the most kind of basic type of plot. And then another option we can do is encode the color, which is gonna yeah, so this is going to tell it use the other, like a third dimension. So we're already sort of visualizing two of the dimensions, the miles per gallon and the horsepower. And then, yeah, pretty quickly we run out of like visual space or dimension, so to speak, to use. So you can, not with Vega-Lite, but there's other options, like you could do a 3D plot, or in this case, what you could do is encode a third dimension with the color. So that's what we're doing here, saying like all of these, red dots are from the USA, whatever, for example. So this is corresponding to this field. So that's that. And that's what we've got here. So just a quick note on the available data sources. So this key here, like we saw, is kind of like one of the most important ones, because obviously without any input data, you can't have a graph. So Vegalite expects tabular data, by which it means like basically lists of maps of things. So it's tabular data in the sense of like where the header row is kind of mapped to each subsequent row. And so you can give Hanami just explicitly a vector of maps, like Clojure maps. And if you're doing that, what you need to give it, you would make this key just data. So if you're doing this, so yeah, so there's different ways to supply the data basically. And if you're doing an explicit map of things, it's going to expect a vector of maps that all have the same keys. And then the values are going to be what gets plotted. So you can also supply Hanami with a URL, in which case what we're doing here, you would use udata. And that's going to expect a relative URL, like something like this, if you're serving it on the same file, like at the same port, or a fully qualified URL, like in this case. And sometimes you can run into like sort of permissions issues with this. So you have to be careful that the data is actually publicly available to any requester. But if you give it a CSV, what it'll do is sort of automatically transform it into this format. So it'll basically like zip map the headers with each row, and then you'll get a chart that works. So yeah, so what we want to do, sorry. Okay, so yeah, there's this, and then there's a couple other options. So this one I've not used yet, NData. This one expects a Vega data channel, which is something interesting I haven't really played much with, but you could use it to basically make like live updating charts, or sort of like charts that take like a data stream almost, which is a possibility. And then, so these three correspond directly to Vega-Lite data sources. And then there's a last one here, which is supplied just by Hanami, that you can give a actual file path. So this can be a path like on your class path, so like in some sort of resources place or whatever, or just like a fully qualified path to a file on your computer. But again, it's the same thing. If you give it CLJ, Eden, or JSON file, it's going to expect it to be in this kind of format, a map or a list of maps, all with the same keys. And if you give it a CSV, it will automatically convert that to a vector of maps. And so there's lots more information at the, on the README for Hanami, which is this. It's a really, really nicely done README and lots of info there. But usually so far I've mostly used either just give it a URL, and if the URL doesn't work, download the data yourself and give it a CSV or a JSON file. So this might actually be not a bad time for a short little break. I guess I could say a quick little thing about just data sources, and then we can, and then yeah, I was just going to look at actually building up a few graphs ourselves. So sorry, I lost my spot. Yeah. in terms of like finding data, so one that we're going to use today, so basically we'll build together this chart using data from the UK government's climate change, whatever thing. So this, yeah, we're going to like recreate this graph, and there's a bunch of ones here. So this is actually, if you go to like the source, this is, in the interest of full disclosure, a platform that Swirl, the company I work with, like builds and maintains. But this is basically a decent source. Right now it's still in beta, but kind of like a platform where you can access a bunch of data sets that the UK government publishes for free. And most of them are licensed like publicly or with some sort of open government license. And then there's other cool places too. This is the Kaggle sort of data sets, like bank or whatever has tons and tons of cool data. So anyway, yeah, at the end of the day, your graphs are only as good as the underlying data. But that's one pro of this government data, is usually like sort of meticulously curated, so it works okay. So yeah, I think it's a little earlier. We're only about 35 minutes in, but I think maybe this would be a good time just to take like we'll take a 5-minute little pause in case anyone wants to grab a drink or whatever, or get something set up. Or if you haven't yet set up a clerk notebook with these Hanami namespaces, you could do that and take a minute. And then when we get back, we'll build these together.
Sounds good. And this is a reminder that if you have any questions or comments, this is a link to Zulp chat. So please put your comments there. And we'll pause the recording for now. See you in 5 minutes.
Let's explore together. All right, so yeah, so like I said, we will work together and basically build this graph in with these tools. So yeah, like I said, the data set's available there. In this case, I just downloaded it. You can download it here as a CSV if you want it yourself, or it's also committed in that repo. Oh, sorry, I just saw the question in the Zulp. Blah, blah, blah. Interesting. Sounds like a problem with the REPL or something. Hopefully it works. Yeah, that's interesting. So yeah, if you look at my REPL, when I run, yeah, this, for example, I do have a bunch of logging errors, but I always do. And then when I run this, it will load my namespace here. So yeah, you'll have to run this separately, or whatever the actual name of your file is. Okay, but anyway, yeah, hopefully everyone's got something more or less working. And yeah, like I said, so I just have actually downloaded this data separately and stored it in this project. It's also committed in that repo if you want to grab it yourself, or yeah, you can download it and put it anywhere. But in this case, I'm going to work with the file directly, just because there's sometimes some issues with accessing stuff with like CORS permissions and whatever. So, okay. So anyway, yeah, looking at, so this is the final answer, so to speak. But we're gonna build it up kind of bit by bit just to see what Hanami's capable of. So this is the scary part. Coding in front of people always makes me scared, but anyway, we'll give it a shot. So, okay. And I'll do it here just to make it easier. So basically we start with like our most basic thing, which in our case will be a line chart, and then render it in Clerk. This, and I'm gonna move it up here just because Clerk for some reason always resets the scroll and it's annoying always having to scroll down. So anyway, so here's our graph, and there's, as you can see, nothing there, obviously, because we don't have any data. So if we give it the data, and like I mentioned, one of the options is to give it an actual file, either JSON or CSV. And so, like I mentioned, I've got the file just here in the project. And this is in that GitHub repo as well, or you can download it directly from the whatever the British government agencies called their website, and give it the path here. We will show something. Resources. Okay, so there's still nothing because we're not we're not telling it how to encode the data and what fields to actually use for these lines. So this is maybe a decent opportunity to point out a couple other cool things that Clerk can do. So Clerk can also sort of visualize or quickly explore tabular data. So if we give Clerk this file and tell it to read it as a CSV, and then, oh, I don't actually need that one. Tell it to use the first row as the headers and then render it as a table, we can get just a quick glance to see like what's even in the data. And so here we can see the columns that we're working with. We've got year, geography, measure type, temperature. So we'll plot year and annual mean temperature as on our X and Y axes. So that's going to look like up here. Again, so if we, okay, let's count this out and we inspect so far what we've got, what we're working with. Our Vegalite specification so far looks like this. I've just commented out the file because otherwise it'll print the entire thing, which makes my REPL really slow. But we can see right now it's using this X and Y, just like straight up X and Y strings for the fields, which is wrong. And what we can do, yeah, so if we check out the default encoding, oops, default, it's going to be this whole thing. And so we don't need to specify the entire, we don't need to like overwrite this entire map. What we can do is just replace like specifically the fields that we care about. So in this case, it's going to be the X field, which is just X down here, and then the Y field. So that's what we're going to do. So we'll say X is year and Y is annual mean temperature, I think it was. So if we save this, now we can see we have some data. And so this graph is kind of just the beginning of, yeah, what we're going to keep building. So yeah, from here, there's like a bunch of problems, obviously. One that we can fix easily is getting rid of all this extra white space on the bottom. So what you can do is say, set the scale of the y-axis to not require 0 as the baseline. So this basically at this point is just like requires digging through the Vega-Lite docs to see how to do stuff. But that's how I knew how to do this, was I was just looking up, you know, I think there's some links, actually I included links here. So these are links to the relevant parts of the docs. Oh, I should mention too, this entire like completed version of the workshop is in that repo as well on a different branch called completed workshop, I think. So if you want to follow along, you could switch to that branch or refer to it later or whatever. But anyway, yeah, so there's the relevant parts of the docs where it explains, you know, to get rid of that. Another thing is these year labels are right now being interpreted as numbers. What we can do though is tell Vegalite via Hanami that the type of this, so you'll see, yeah, this encoding here, for the X field, we've got all these different attributes. So field type, bin, axis, blah, blah, blah. So this type defaults, as you can see, to quantitative. But if we tell it it's temporal instead, then it'll interpret these numbers as years and render a little bit nicer. I guess, yeah, we can just quickly make it wider, spread out the data a bit more, but we've still got too much going on. And the reason, I guess my browser's, this is a really low resolution, so maybe it doesn't need to be that wide. Okay, the reason we've got all this is because if you look at the data here, these geography, or sorry, the years, years just one dimension. So this is basically like what some people think of as like a data cube. So it's got all these different dimensions, but the way that we've sliced it and the way that we've sort of captured it in this specific download is that we've kind of locked, like we've selected year and annual mean temperature, or I guess in our graph rather, but we still have all these geographies mixed in. So we've got like Scotland, Northern Ireland, Wales, and probably multiple values for the same year because we're dealing with all these different geographies. So what we can do right in Hanami is filter it down to just one of these values. And so that's possible with this part of the vocabulary that I mentioned before, which is the transformation. So if we say transform, in the Vegalite specs, you'll see, or the Vegalite, sorry, docs, transform takes a list of transformations. So it's always a vector. And the first one we can use is a filter on the field geography and say only use the ones that are for the whole UK. And so what that's going to do is give us sort of more what we're looking for. And that's pretty close to what we were going for. The last step, the last thing we want to do is try to add that trend line. So yeah, where'd it go? Here, they just have a, like, you know, this, I guess it's not super obvious. I don't know if it's actually specified anywhere how they computed that trend line, but we can do something sort of similar, even if it's not computed in exactly the same way. And to do that, we'll use this layering rule. So we've got like our pieces or our vocabulary built up. We've got, like, you know, we're using line markers and we've got the encoding specified and we've got the data. But now we want to say, okay, like basically put another chart on top of this one, but you know, it's going to be the line itself. So yeah, so to do that, first what we can do is just move this base kind of layer into, like, make it one layer of a multi-layer chart instead of being the whole thing. So Hanami includes, I'm just gonna put this over here, some helpers for that as well. There's a kind of spec or a map for a base kind of layer chart. You can see what that looks like. Again, like all of these templates are really just maps. So this is what the layer chart looks like. And if we render it, there's not going to be, oops. Okay. There's, yeah, it's pretty empty right now. So we've got, yeah, just width, background height, and then layer, which is this like layer key. So that's how we know we need to replace this one or give it some value. So we'll go ahead with that. And layer is going to be a list of layers, obviously. And what we can do for now is just like put this one inside. And that should, I'm just going to fix the indentation. Oh, I guess I can't. So yeah, so now I guess it didn't look like it refreshed, but we've now sort of built this layer chart. It only has one layer, but it's still rendering the same thing, which is good. So I guess, yeah, you can prove this is a different layer here if we give it a different color. So the marker color, this is, and discovering like which ones of these you need to override. This is, I didn't find like a super fast or easy way. You kind of just have to like trawl through the docs and see like which things you need to overwrite where. But anyway, eventually you can discover M color is going to replace the mark color. And if we make this like fire brick, which is kind of burgundy, hopefully,
Oi.
oh, sorry. And then I want to make sure this is actually rendering. I don't think it is anymore. Yeah, I hope that keeps working. Anyway, so yeah, so there's our second layer. Okay, now it's picked up. Sometimes, okay, this is, I don't know why Clerk does that, but sometimes it's like stops watching my files or something. Anyway, so yeah, you can see this one is actually rendering 2 layers. They're just right now happen to be identical, but that red one is on top. And so what we can do to add that trend line is another transformation on the data. And this is one that I discovered in the Vegalite docs with help from some folks in the sort of meetups. Yeah, here. So this is locally estimated scatter plot smoothing regression. And this is basically something that's just supported like out of the box in Vegalite. And what this does is going to give us the trend line we're looking for. So, right. So here, instead of just mirroring the data, making the same graph except red, we can add another transformation, which is going to be this locally estimated scatterplot smoothing thing. And we'll tell it, do that on the y-axis with, oops, the values from the x-axis. So here, if we refresh that, we've got our graph. And this is, yeah, basically, you know, how you go about making something, one of these in Hanami. Oh yeah, there's a little thing here. Right, that's like included in all of them by default. So yeah, so I guess since we have a little bit of time left, I wasn't sure how far we'd get, but there's another cool feature in Hanami that we can explore, where you can have these template local defaults. So the idea behind Hanami, I guess, is like, if you're doing this kind of stuff all the time, like obviously you can just write these Eden maps, you can just write your Vegalite specifications as straight up Eden, but then like pretty quickly you start extracting like common patterns and merging stuff together and composing these graphs yourself. And then you eventually realize like it would be cool to sort of just do that recursively and pinpoint the specific values you care about. And so basically that's kind of what Hanami does. So you don't have to stick with only the ones that are built in, right? So we've got like layer chart and line chart, but what you could do is if you were doing a lot of stuff that, you know, if you're building these kinds of graphs all the time, you can build sort of your own like templates or base kind of charts or layers or graphs or whatever. And so Hanami supports that with these, what it calls template local defaults. And so as an example, what we can do is like make our own like trend chart and see what that looks like. So it's going to be, you know, some sort of Hanami transformation. We can build this up. and go from there. So yeah, our trend chart, basically we can start extracting stuff out of this. It's going to be the exact same in the end. But we can kind of build it up from here. So like you'll see, so one thing that we can do is like a lot of these values are the same in both layers. So what we could do is make like actually, let's just do it this way. We can start extracting stuff out. So we can have a trend layer, and we'll start with this. Except instead of, right. Okay, so we're basically, we want to make this kind of work. Get rid of all this. So if we just transform our trend layer. Okay, so if we just do this, if we just say, take the line chart and associate all this extra stuff with it, it's not going to work. And that's part of the reason is because of the way Hanami like transforms things and kind of the like when substitution variables get subbed in. So basically none of these are actually like these can't be keys in this chart, like map shortcut thing. So this is our line chart. And what we actually want is for like these values to be the defaults in here. So like, you know, in the encoding, there's like an X nested in here. We want this X to be, that X to be year. So Hanami supplies this like special, this is like a magic key thing called template defaults. And what you can do is give this a map of things, and then it will use those. It will use those in the template. So if we do this, now Hanami is taking this map of stuff and applying these as the default values, but only in the context of this, like the transformation for this one thing, if that makes any sense. So another thing we can do to make our trend layer simpler, like we probably don't want stuff that's so specific, like the data, for example, so we can move that to the top level actually and out of both layers, and it should still work. We can, I guess that's actually probably pretty okay, like this transformation. Okay, so anyway, so now we've got this trend layer, but if we, oops, if we just make another one, this one is not quite the same, so we need a couple of custom things. What am I looking at? Sorry. Yeah, right. So, okay. So far, so we can basically like delete the stuff that's the same. Let's do it this way. So yeah, instead of a line chart, we'll use our new trend layer. And then we can get rid of this stuff because it's all the same. And this transformation. But I think this is still not gonna work. Oh my gosh, it did work. Okay, well anyway, there you go. Okay, so oh yeah, okay. Yeah, I mean, I guess, so this is pretty trimmed down. You could even like go one step further and make this like a trend chart, for example, and like say, okay, we've got, start with our layer chart. Oops.
Yeah. Kira, I could just.
Yeah, John's here. Oh, great.
One thing you could do is in the layer, trend layer is get rid of the transform altogether.
This.
Yeah, if you get rid of that, and then in your, when you supply it, and you're transforming the, when you're actually using the layer, then that stuff will go in. But the first one doesn't need that. So you don't even need that transform. So if you take it out of the defaults,
Take it out of the defaults and then just put it in.
in the trend layer, and then you don't need to do it again there because you've already, you just need the, yeah, you need the field only.
Okay.
You would need that field, and then the I guess the one down would also need the field, I guess.
Right. So yeah, anyway, there's definitely lots that
Yeah,
you can do.
You could take, yeah, you can just take a lot more of the stuff out of there.
Yeah.
But it's,
And then,
yeah, whatever. I mean, yeah.
but yeah, but no, that's really useful for sure. So anyway, so this is like, yeah, just an example of how you could like simplify things. And then, yeah, if you were doing this all the time, you could make your own, like, yeah, thing here and say like, okay, my trend chart has 2 layers always. And, you know, one of them is the trend layer with this transformation. And the other one is, and, you know, here you could substitute this instead of saying like, geography, you can make your own, like, whatever, transform field and transform equals, sorry. And then I think if we do this in our own, for our custom thing here, we'd move these layers to the definition up here, but we want to replace these ones. So we could say like, okay, transform geography and transform. Okay, I think that'll work. Okay, maybe not. Anyway, that's kind of the idea. So, okay, I'll undo it back to the plate where it works, and then we can look at one more example. I guess we're just about out of time, but yeah, another, so that's, I guess, just, yeah, I wanted to illustrate the template local defaults. And then, right, like, okay, here's in the completed one where I've done like, you can make your own chart that has both of these layers, and instead of like hard coding the trend line layer, you could pass it in as a variable and then give it a default like here, but where we, you know, make a chart with a different color trend line or whatever. I mean, I guess we're just about out of time. So like, does anyone have any questions or comments or anything like that?
There is a question in this chat about export.
Oh man, sorry.
So maybe you can answer that.
About, oh, the Zulp. Where did the Zulp go?
Well, the question was actually in this chat. So get to it.
Oh, how would you export a chart for use in a web app? Yeah, so there's different ways. Like one way, you could just actually like build it like this in Clerk or whatever and save it as like a PNG, or this is going to open it in Vega's own editor like this. And so actually this is interesting. Like you can see here, this is the so we've got our Hanami graph, which is this, and this is, I mean, a little bit cheating because we do have some stuff up here, but it's still like, I don't know, 20 or something lines of code. And then this is the Vega-Lite spec. So this, I guess this is not totally fair because it's actually like inlining all the values, but this much is what we accomplished in Hanami, and then there's probably some more stuff at the bottom. So anyway, yeah, as far as exporting it into an actual web app, so yeah, you could save it as like an actual image and just put it in like as an image on your web page, or you could like include the Vega compiler, which is, so Vega is all open source and public. And then if you wanted to do that, you could do that way. And then, but I guess obviously your website would require JavaScript to work, but you can do that way. So anyway, like I said, so this is, yeah, just as we're wrapping up here, you know, the Vegalite documentation is super, super good. There's tons of information here about all the different possible transformations you can do and all the different marks you can do. There's tutorials that go over sort of how to build different things. There's lots of examples. So anything you're trying to do, you can usually find something that's similar and start from there. And I guess, yeah, one other thing that's cool that is put out by the makers of Vega is this thing called Voyager. So if you go to just vega.github.io/Voyager, it's like an exploration tool for data sets. So if you upload, like if we upload our temperature data set, what it does is basically just like auto generates a bunch of just miscellaneous graphs. And like, in this case, these aren't the best because it's not exactly accounting for like, it doesn't handle data cubes super well, but it can be a good place to start. If you just like don't even know what to do or like what is even in a data set, you can throw it in this. And then these, you can start with these, you can copy them. If you copy that, it's going to be the Vegalite. Like if I paste it here, this is the Vegalite spec. Or you could throw this into like a JSON to Eden converter or whatever and go from there. But yeah, so there's that. And I guess that's just about all we have time for. There's one more example in the repo if you are interested in, like, I just turned that graph from earlier, the Vegalite spec that we started with, into a sort of Hanami looking one with like some other custom layers and stuff like that. But it really is just all about like, you know, building up these maps of things. And the thing that makes Hanami really nice and sort of where it helps is just kind of when you get into making the similar types of layers and similar types of graphs over and over again, you can just like specify the thing you want to replace one time and it will just sort of go through and recursively deal with all of it. But anyway, I guess, yeah, I'll leave it there with about 3 minutes to spare.
I think we have more time.
Okay. Oh yeah. Did we say what time did we start? 9:40. Oh no, you're right. 10:30.
Yeah,
okay.
Almost 20 minutes. So if you want to do another example, if we want to do more Q&A, anything.
Sure. Yeah, sorry. I was like totally on a different wavelength with the time.
We have a
but yeah, is anyone
from Sebastian?
Hello.
Hello.
Yeah, there's a I'm trying to get it working on my local machine, and something that I noticed that wasn't documented in the server was how to set the bind host, because currently I can't access the page that it's serving, and I wondered if you had any links to documentation for the internals of this. Thank you.
For Clerk itself. So yeah, I'll paste.
Yeah.
This is I'll paste the info for Clerk, and yeah, there is a way to specify the port that it uses. I think maybe it's not even here, but you just give it the port like this, and then you should be able to give it whatever custom one you want. But as
Oh,
far
yeah,
as like, oh, sorry, go ahead.
Yeah, I was meaning the bind address. So in that case, it's localhost, but I would like to set it
Oh,
to 0.0.0.0, so I can access it from my machine.
I see what you're saying. I'm not sure, to be honest. You might, I think it's hard coded actually. Web server. Yeah, I think it's, you might have to do something fancy with like host files or something. Yeah, okay, here. So yeah, I
Oh,
think
yeah.
it's just
Hard
when
coded in
you,
there.
yeah, exactly right there. So when you're browsing, it's going to go straight to, well, mind you, that's just browsing, but it uses this under the hood, this beholder thing and this web server thing.
Yeah, I see it starts the web server with port, but doesn't give you any option to pass options down to the web server.
Yeah, exactly. So there are other options too besides clerk. Like I just chose it for this workshop because it's kind of a convenient, like, you know, environment for quickly iterating on stuff. But yeah, there's other ones like note space is a cool one. And then also you can just do your own thing, like rendering Vegalite specs some other way. But yeah, unfortunately it looks like Clerk doesn't supply a way to do that. Find a start.
Well, thank you very
Here.
much for your talk. This is somewhat self-imposed since I've resolved to only ever run development stuff in Docker containers. So
Oh yeah.
maybe this is something I've put upon myself, but thank you very
Oh, I'm
much.
sure
It's a
it's
really nice talk.
possible. You can. Oh, thanks so much. Yeah, I think maybe if you try something tricky with your hosts or something, you could trick it into thinking. I don't know. Anyway, it's interesting.
Yeah,
But yeah,
I
thanks
need
so
to
much.
find some way to share the networking stack or something.
Right. Yeah. Yeah.
Anyway, this was really
Cool.
interesting. Thank you, because I'd been looking at graphing libraries for Clojure, and I hadn't come across this one. So thank you very much for your talk.
Nice. Oh, my pleasure. Yeah, so that's cool. Yeah, Hanami is definitely a fun one. I guess yes, if we have like 15 minutes, I could quickly go over just like what I did with this. If we start with our CO2 levels as just the Vega, stuff. We'll see this. How does Hanami compare to Oz? I have never heard of Oz, so I'm not sure. Unfortunately. That's interesting. Yeah. Is Oz another Clojure library?
Maybe I'll comment briefly.
Sure, yeah.
So Oz is a tool by Christopher Small for data visualization and literate programming, this idea of creating a notebook-like view like we have here. And I think it has been inspiring a few of these newer tools like Note, Space, and Clerk that we have now. And Oz does support showing Vega and Vegalite plots. So it is actually compatible and composes well with Hanami. You could use your Hanami plots in Oz, and we will have a workshop about Oz by Christopher in a few days, and it will be wonderful.
Oh, that's great. Yeah, that's great. Yeah, sometimes it's hard to separate all the different things. So yeah, it's definitely like worth like emphasizing that. Yeah, Clerk is like a totally orthogonal tool, and it's just one of many ways to render these things. It's just like, yeah, one convenient sort of tool to convert this stuff into actual HTML that I can see in the browser. But yeah, there's certainly lots and lots of other ways, and it's by no means the only way to use Hanami. Hanami even includes its own, like it's capable of so much more cool stuff than I could get into today. But there's even like a little framework for building, yeah, basically apps, or like showing different visualizations or composing them into like almost a dashboard type thing, like built right into that library. And yeah, anyway, so there's definitely lots and lots of options for that kind of stuff. So
there is also a question in Zulp chat, if you have a minute. And
yeah,
it's asking which parts are Hanami and which are Vegalite.
sure. Yeah, so yeah, I know that part's like confusing. So that's, yeah, what I was hoping to avoid. So right, so Vega-Lite is this like JavaScript library that takes JSON data structures and turns them into graphs. So a Vega-Lite specification is just a JSON, like just a map, a JSON object, or you know, if you can just convert them one-to-one to Eden. Like if you just literally copy paste this into a JSON to Eden converter and stick it into Clerk, it'll render. So that's all I did here. So this giant thing is just from one of the examples on the Vega-Lite page up here. Then I convert it to Eden and put it in, and then it renders. And then, but so what Hanami does, like at a high level, you can basically think of it as just like a sort of fancy way to like recursively replace specific keys in Clojure maps. It's just nice. It's like a nicer way to do it than like constantly meta merging all of your own maps and stuff. And it does a lot more than that as well. But yeah, so this, like a straight up map of information, is Vega-Lite spec. And then Hanami is where you get these like base forms and then substitution keys. And then this transform function is like kind of the core of the whole thing, which takes these keys and inserts them into whatever template. So basically, yes. So you've got, so there's a bunch of built-in templates. So there's like line charts, point charts, a couple that we saw. There's a bunch of other ones. You can also make your own. So like if you look at like the line chart, it's just this. It's just a map. So you could literally, which is like, so that's what I did for this. Like what we can do is start, you can make your own like stacked decade chart or whatever, and start building up your own thing. So like I'll start with a line layer, which is just like a line chart, but a little bit less stuff. So really it just tells me like, it means I don't have to manually specify the type of the mark as a line. But I also want a bunch of other stuff in here as well, like encoding. And Hanami also supplies like sort of sub maps of stuff. Like this one is XY encoding, which gives you this map. But these are all just like, at this point, these are just Clojure symbols, like straight up, like that's just literally a key with capital letters. It's not like a magic thing or anything. It's just data. It's all just data all the way down. And so, and like the caps thing is just like a convention. It's not like, they're not magic or anything. It's just like a convenient way to be able to like visually really obviously see which ones are going to be substituted by Hanami. So
But I could replace all those with lowercase and it would still work in theory.
Yeah, so yeah, we
I
can.
mean, I'm asking just to
Yeah.
like, partly I'm just trying to be able to navigate the Vega-Lite documentation
Right.
in order to use Hanami, right?
Sure. Yeah, totally. So yeah, I see what you're saying. You can, yeah, you can. So like if we go back to our like trend chart, for example, so we've built this like custom trend layer thing, and our custom trend chart is going to have a layer here and another layer with this this key. But if we gave default value, so if we said like, okay, the defaults here for our, oh sorry, this should actually be here. The defaults should be this layer. I can give it like, yeah, okay. So if I say this, instead of Firebrick here, just make this trend color. This doesn't have to be caps. Like I can make, this can be totally arbitrary, whatever I want. 2, 3. And then I need to give it a default here, I guess. But that's gonna give us the same effect. And then in my, when I'm using my, oh, I'm not using it. Okay, so if I change this to a trend chart, I don't need these layers anymore because we specified them up there. But if I want to override that trend color, I can make it like orange. And now it's what it's doing is substituting this up here, which is then again like its transformations like all the way down. So this M color is the mark color, which is used in some like higher level part of the map. And then you can just specify whatever arbitrary thing you want in your own custom thing. And then that way, like, so again, like where this comes in handy is like if you're doing this at work or something and you're building like 1 million of these and the only thing that changes is that color or whatever, for example, or like the field you want to filter on or something, then you can do it that way. But yeah, these ones are arbitrary. There's a bunch that are built into the library itself. So those ones are all caps all the time. But any custom ones you do like this can be whatever you want.
So colon capital X, that's a Hanami thing. And when I see X colon in Vegalite, that's something different. It's a different association.
So
Where it's lowercase in Vegalite and uppercase in Hanami.
yeah, so yeah, exactly. So in Hanami, that capital X is like the default value for here, for the X field. But in Vegalite, when you see X, it's the key. It's going to be so yeah, if you look at like, where's that Vegalite spec? So here, yeah, this little X is the key for the encoding map. And yeah, so I can see why that, yeah, that's maybe a little bit kind of,
So that'll help keep me from getting confused. Good.
Yeah. So yeah, one way to think about it is like Hanami replaces values. Like you're never replacing keys with Hanami. You need to specify the keys yourself. So like this like line chart, for example, like if you look at the source, it's literally just a Clojure map. So, well, it's a little bit, nested, but yeah, see, like this is literally just straight up Clojure map. And these keys are all the lowercase things. So if we follow this all the way down, right? If we look at this encoding base, oh, where's like the XY encoding there? So XY encoding. So there's the little X. So that's the key that's going to ultimately end up in the Vega-Lite spec. But Hanami replaces values only. So you're never replacing keys. But in Hanami, yeah, just this could be called like X. Oops. All right, I can't change this. Anyway, yeah, this could be called like X field or X whatever. It's just that, you know, the author of the library has just used this as a shortcut because it's like sort of, it's obvious when you're using it, it's like, okay, yeah, X is going to be air, Y is going to be temperature. But yeah, Hanami is just replacing values all the way down. And like, yeah, you see that here with like, if you want to extract that one instead of hard coding it as like some color. So like if we hard code it, now it's always going to be green. But if I want to make it like, I don't want it to always be green, I want to make it a substitutable value, then I can give it a default maybe, but without that, I can pass it into the transform. So like, yeah, like we saw earlier, like Hanami will just transform arbitrary maps. Like if I say, you know, this is my special key, and then give it like encoding, for example, and I run this, oops, it's going to replace that value with the default for the encoding. And then, you know, remember not everything has a default. Sometimes the default is like none, which means it gets deleted. But yeah, does that help at all? Anyone have any other questions?
I just tried it out, and it's actually really possible to get Hanami output right into Portal. I don't know if you guys know this. The only thing I had a problem with is that sometimes Hanami prints out the mark type in a map, and Portal can't really deal with that. So you'd have to like desource the type thing and just put a circle in there. But like the final example you used, I could just tap that into Portal and it's displaying without a problem.
Okay. Cool.
I had a question though. Is it possible to get the Hanami stuff without the whole serving side? You know what I mean? Like if I just want the transformation so that it's easier to build up Vegalite specs or Vega specs, I don't need like the front end and I don't need the back end. Can I get that out without like depending on all the stuff beneath it?
Yeah, so like in this case, so this particular server and viewer and stuff is Clerk, which is just a totally separate library. But then, yeah, within Hanami, you can certainly just like only, like Hanami it's all one library. But you can just require the parts you need, like the transform, for example. But this web server and file watcher and all that stuff is separate.
Yeah, I know. But like in Hanami itself, there's like it has its kind of its own server and its own front end.
Oh, I see what you're saying.
As far as I can tell.
I see what you're saying.
And I like not to depend on the whole thing if I just need the transform part.
I mean, I don't. Yeah, so it is just one library, but you can like, you know, you don't have to bundle the whole library, right? You can just like build your project to only include the namespaces that you're actually using. But yeah, as far as anything beyond that, that would require some sort of, I don't know, maybe there's some magic thing you can do with unbundling Clojure libraries or something like that, but I don't know.
Okay,
Yeah.
thanks.
Yeah. Cool.
Right. So looks like now we are getting.
Now we're actually, I'm sorry. Sorry about that.
So thank you very much for a wonderful talk. The discussion on Zulp may continue, so that's a place to
Yeah.
follow up.
Yeah, I should
Um,
mention that I'm on the Clojure and Slack and the Zulp and GitHub and whatever. So feel free to ping me anytime. And definitely there's also like way more cool stuff that you can do with Vegalite. There's like, I didn't even get into any of the interactive stuff, but you can do like interactive charts where you can click on them and stuff, which is cool. But anyway, but yeah, feel free to message me anywhere on the internet.
Yeah, thank you very much. And thanks, John, for writing the library. And thanks to
Yeah.
Daniel and Ethan and all of the other wonderful people who organized the workshops.